In this video, we're going to have a look at a quick example of how you would look through a string, compare characters, and increment based on whether or not they are the character you're looking for. So as you can see here, I've got a list of Jean-Claude Van Damme's finest films. We have Time Cop, Hard Target, Lionheart, Kickboxer. I think two of which he fights in underground fighting tournaments is a big pattern in his films. And we have three letters here that we'd like to check for, count, and see how many examples there is in this string. Now you'll notice this is far too big to be listed as one word, so this is stored like an array. Byte-wise, we have each byte represents one of the letters, and this is terminated by a null value of 0, 0. So what I'd like to do is write a little bit of code that can check one character against this list, count the number of times it occurs, and then print that to the console. So let's see how we do that. Well, to start, we would load the address into T0 of Jean-Claude Van Damme. It's an important place to start. And let's load one of the bytes, unsigned of course. We don't want to extend the sign of the byte, so we just do unsigned. And let's store that in T1. Which one will we go for first? Let's go for A just because it's the first one there, because why not? And then we'll loop. I'm putting a loop here because obviously we want to do our counting in the loop. That's the way we always do counting in computer science, well almost always. We loop through, checking every position. If it meets our criteria, we add 1. So the first thing I'm going to do is I'm going to load the byte from T0, because I've stored T0 as the pointer rather than the value at that address. So we want to use the pointer because we want to increment it, and this is an easy way to do so. So what I'm going to do is I'm going to load the byte unsigned, let's say into T02 of the value at T0. Because I can't manipulate that directly, of course, I need to get the byte out before I can compare it. If I try and compare with just T0, I'll wind up looking at the word, or I'll wind up looking at the address. So I'm going to load that byte out, put it in T2 so that I can then manipulate it. Now what I want to do is say branch if equal to 0, because this is a null terminated string. So when I get to the end, I want to just stop and jump out. So I'm going to branch if equals to 0. The value I want to check is T2. And let's say I go to the end. And I'll make a label down here, which is end. So that gives me my initial condition. This is kind of like your for loop when you check I is less than n. This is me saying if it's equal to 0, we're at the end of it, so we should jump. So branch equal to 0 out of the loop. Now what should I do next? Well, now that I have the byte in T2, you might think that the ideal thing to do would be to compare that to whatever is in T1 to see if they are the same. But actually, what I want to do next is increment T0, because if I do the comparison next, then I'll wind up in this infinite loop of just going between two comparisons, comparing the same thing over and over again without incrementing the address. That might sound like a lot, it'll become a bit clearer when we see the code working in practice. So what I'm going to do is I'm going to add in the immediate value to T0 of whatever is in T0 and 1. That's my increment, that's my I++ in this example. So it takes the pointer, increments it by 1. It's only 1 because we're looking at each letter, and each letter is of course a byte, so we just want to increment by 1 at a time. So what do I do next? Well, now I want to branch if the things are not equal. You could also use comparison operations to say, are these two letters equal, and then branch if not 0. But what I'm going to do, branch if not equal, and I want to say that's T1, that's the character we're searching for, and T2, which is whatever's stored there, the byte that we're at, or the character we're at in the list so far. And if I fail this, I want to, no, not dupe, I want to go to loop. And that'll take me back up to the start of the loop. I don't branch to the end here, because if I've encountered a situation in which they're not equal, I want to say that I've gone to that bit, I've checked that they're not equal, and then I jump back up to the top without incrementing my count. So next, I would say, if this condition fails, that means they are equal. If they're not equal, they must be equal. And in which case, I'm going to start count in A0. Just going to use A0 because it's going to be 0 when we start this code, so I might as well just add on to there. So I'm going to add a value of 1 to say, okay, we had a condition that said branch if these two are not equal. That didn't succeed, so we must have fallen through in the case which they are equal. So I add 1 to my total to say that's one we've found so far. which is equal to the character we're searching for. And then I want to do j to loop. And that takes me back to the top of the loop. So this branch if not equal and this j loop are two cases that we're checking. One saying, are they not equal? Go back to the start then to check the next character. And then the one saying, okay, in the case where they are equal, we increment and then we jump. Okay, so now, because I've put my running total in A0, down here I can just do load into immediate V0, and then I can do a syscall, and that should print for me. Let's compile this and see if I've got it right. Oh, no, I need to give that a value. Let's give it 1 because we want to print out the decimal. Let's compile and see if we're right. Okay, so far so good. Now we should see, if we go through this code, we'll bounce between our branching instructions quite often because we check every character, and then occasionally we'll go to the register of A0 and see what's stored in there. So let's run this code and see what happens. So I've set this down a little bit. Let's increase the speed and see if we get any counts out in the end. I'll increase it a little bit more. So there we go, we counted 3 occurrences of the character A. So let's quickly reload another one and do this again. R should be more R's here. Let's compile and run. I'll turn up the speed. And as you can see, it's going through the same steps. And there we go, we got 4 R's. So let's do it quickly with X. This should only return 1 because we've only got 1 in Kickboxer. Let's compile, play, and I'll turn this up to maximum speed. There we go, we got 1. So that's how you would look through a string using MIPS. I hope you found this useful. If you have any questions about what we've done today, please do let me know. Thanks.